Good afternoon, everyone. Before the presentation, I'd like to just get an idea, I know everyone knows DMN, but how many people actually heard of field, the expression language in DMN? Okay, so I think this afternoon we'll actually spend a little bit more time to talk about field. I think this is one aspect of the DMN that was very important, and I work with one of the person who is in the committee. He's working at Oracle, Gary Hallmark, and we are going to talk a little bit about field today in this afternoon. So let's start the Ignite presentation, okay? So, okay, first of all, my name is Alvin, and I'm a developer from Oracle Process Cloud development team. And today I'm just going to talk about the new decision service engine that we are developing at Oracle for Oracle Process Cloud. So we're going to introduce the Oracle Process Cloud, and we'll talk a little bit about DMN, and then we'll talk about we'll give an overview of the demo, you know. So, and then I think at first I give a few words about Oracle Cloud, right? The Oracle Process Cloud is our PaaS platform for business process automation. It offers many of the same functionalities as the Oracle BPM suite. So now I think we can switch a little bit over to the decision modeling service. The decision modeling service is a DMN-based decision engine, which is an expression evaluator with REST-style interface. And this will be offered in Oracle Cloud as an alternative to the existing Oracle business rules. So here's some decision requirement graph here, and you can see that we have decisions, sub-decisions, dependencies, reusable logic, decision logic called business knowledge models, and input data. So these are all stuff we are all familiar with. Now, this is the box expression. Within each of the box in the decision diagram is a box expressions, right? Box expression is the notation for modeling the decision logic. So the decision logic in the expression is actually implemented in an expression language called field. Stands for friendly enough expression language. So the box expression can reference each other as you see in the diagram through the names. So let's go and talk a little bit about the expression types. So without just going through it, these are the expression types in field. But one couple things to remember about expressions is that we cannot do assign values in expressions, right? And then rather, an expressions always yield a value. So the first box expression we talk about is the decision table here, and this is something we're all familiar with, input expression, output expressions, and then we have a hit policies for defining what happens when the rules overlap. So the other thing very common is the if-then-else expressions. So this is the most commonly used rules expressions. And inside the box, you can use the literal expressions, or we can actually include another box expressions. The other one that's very interesting is the for-in return expressions. This is for iterations, and you loop through a collections of repeating elements, evaluates an expression for each element, and then returns the combined result. So in this demo, we are going to show how to use the for expressions to iterate through the line items of an order. So we'll calculate the approvers for each line, and then returns a combined result. So the other things we want to talk about is the item definitions. This is another thing in DMN which is used as a type definitions for defining type structure of data items. Mainly it's used in the input data element and function arguments for validations. So after a decision model is completed, user can define test data in the decision model for testings. So in our tools, we actually provide play buttons to test the decisions against the sample data. I'll show it in the demo later. So finally, it's the decision service. Well, once you design the decisions model, you want to expose it, and decision service is for encapsulating one or more decisions in the decision model for external consumptions. For instance, a BPMN process can call a decision model through the decision service. So here, this is our demo. This is a purchase order demo that we're going to have a list of purchase order with headers and line items. And then the output will be a list of approval attributes. And the approval attributes will tell how the item should be approved and who should be approving it. The demo will show how DMN can handle multiple line items. This is very important. This is one of the key element of this. So this is the approval logic that we are going to do. The header approval will have a measure from a particular supervisory level based on the PO amount. And the line items, it will require one or more approvers from a different cost centers because these are cost share items. If it was a cost center shared by multiple cost centers. So this is a work in progress, So we don't have, we are still working on a decision graph UI, but for now we actually have a list UI that we are going to use for this demo. And then this demo is going to cover the purchase order approval. And I actually want to add another demo in front of it so that we can get into a purchase order approval after that. So let me just give me 1 second, and I'm going to switch over to the demo view right now. So this is our UI. So first thing we want to do is I want to show 2 demos. One is a loyalty program demo. So this is a demo which actually typically a retail business used to reward the customers with extra discounts or reward points. So let's see how we can build this demo using DMN quickly. So here I'm going to create a new space first, and the space is actually a container that we use to store the decision models. All the related decision models, we can put them in one space. So we're going to call this loyalty space, and we're going to switch over to the space here. And now we can create a new decision models. And the decision models, and I'm going to call it loyalty program demos, okay, simple. And they will be in the loyalty demo loyalty space that I just created. So here we create a decision model, but the decision model is empty. There's nothing in the decision model at this point. So we start building the decision models. And the first thing before we build the decision models, we want to actually provide some sample data. Because if we have sample data in the decision models, we can test the decisions when we were building it. So we get instant feedback on every single decision that we are trying to build. So just quickly and see what we can do here. This is a customer loyalty program. So let's say we create a customer object. And in DMN, there's something called context, which we can use to create okay, so in the context itself, we can actually create some elements. So let's assume that things that we are interested in the customer will be the age. And the age I'm going to build as an expression. I like to make it higher because I can use it for some extra discount later. And then the second interesting attribute will be like a tier, which is representing whether the customer is a gold customer, platinum customer, and these are data that we need to keep, okay? Third element is the transaction amount, right? So these are, remember, these are test data. And I just make this transaction amount to be $50. So finally, I think I want to add this accumulated points, which is the reward points that this customer has accumulated so far. So let's give him 1,000 points. So let's save it. So this is the customer test data that we can start working on. Now, the second thing we like to do is, well, what kind of discount we like to give the customer? So let's say we want to give them a gold member discount. Okay, and we just make this expression. And in the expression, we are going to give a factor. So we're going to give them 10% discount. So the discount factor will be like 0.90. Okay. Another thing we like to do maybe to add another type of discount, which is a senior citizen discount. So let's say if we add this discount here and just create another one and also expression and also 10% for now. So now we actually have built up some important elements to build the other part of the decision model. So now we want to build a decision logic, which is to calculate the discount price based on some conditions. So let's call this calculate discount price, okay? And we're going to build this as a decision table, okay? And let's take a look at it. In the decision table, we need to add some input data. And let's give it another column, so we have 2 columns. And one of the input data I'd like to get is, like you see, some auto-completion here. Okay, the age is one factor, and tier is the other factor. So this tool will drive what kind of discount the customer is going to get. But I'm going to fill in the logic later. So let's just save this. And okay, and I want to complete the outline of the decision model and then come back to fill in the logic. So the next thing I want to do is to finally, I want to actually, after I give the appropriate discount to the customer, I want to give them some reward points, right? And the reward points will be based on certain logic. So let's build reward points called decision, called calculate. Okay, let's call this something I've used calculate already. So let's call determined new accumulated points, right? So this decision logic is supposed to, I mean, let's say we choose, we can use a standout expression to build this, okay? So this logic itself is, we like to see, well, maybe perhaps for the gold customers, for every dollar he spent, we'll give him 2 points for every dollar. And for a regular customer, we give him only 1 point for every dollar. So the condition, the if conditions will be customer dot tier equal to gold, right? So let's save this, and then I'll fill in the decision logic later. So here's the part, right? Just like any cooking shows, I'm not going to fill in everything. It takes too much time. So I'm going to put a chicken in one oven and then get a baked chicken from the other oven. So, so here's my baked chicken here, okay? So in this baked chicken, you see everything I showed you so far is already still there. We still have the logic. And we have this decision table. And you can see this decision table is that we actually fill up all the conditions. For the customer, we have 67 below, and then gold and base. We just have some condition for examples. But here, we actually cover all the cases. For age-wise, it's actually mutually exclusive. So one thing you can see here is like based on the customer age and customer tier, we have an expression here, a literal expressions that actually apply the discount factor, accordingly. So you can see that, for example, you take this one, if it's higher than 67, older than 67 years old, and the gold customers, we are going to take the customer transaction amount, and then we actually apply the gold member discount and the senior citizen discount, okay? So this is all good. Now take a look at the final decisions. When the customer tier is equal to gold, and we are going to take the total accumulated points, and we add, we take the calculated discount price, which is we calculated from the expression below, and we multiply by 2, and this will add 2 points for every dollar the customer spent into his account, right? And otherwise, we just add 1 point to his account here. So after all said is done, right, we can actually test it. So now when we click the play button, you can go down and just look at the logic. So this is the customer, 70 years old, gold, and he spent $50, and the account has 1,000 points. So when you look at the discount price that he actually is paying is only $40.50, right? After including the discount as a senior citizen as well as a gold member, right? And here, finally, this one here, you can see that, the total number of points is at 1081, 40.5 times 2, So let's say one day you just decide that, well, this week we are actually going to give a better discount to senior citizens. And then we say, well, we're going to give a 50% off. So we just do the same thing and then save the model, and you can run the test right away. So when you run the test, you can see that now the price gone down to $22.50, right? And finally, this same thing, the calculation is still going. So this is the first demo that I like to show, because this one here is a very simple use cases, but you can extrapolate these use cases for a lot of situations. And we actually get this requirement from another Oracle application team. Of course, the use case has been watered down for this demo, but essentially they are kind of like similar logic. So finally, I'd like to show another, I still have 5 minutes, so do I? Yeah, I still have 5 minutes. So I'm going to show the other demo. This demo here is actually a more complicated one that I described in the presentation. So here, the use case is I have a purchase order, and I want to send this purchase order to a decision engine to find out who needs to approve this purchase order. And the rules is that if the purchase order have line items, you have to decide whether the line items is approved by one manager, or if the line items actually is ordered by multiple cost centers, you need to actually send it to different cost centers and have a approver from the cost center to approve the line. So how do we do this? Here, I'm not going to build it because it would take a lot of time, but not a lot, but it will take some time to build this. So I'd like to walk through the model with you and see how we can achieve this in one pass. With DMN, with this field language, field expression engine, you can actually send the entire purchase order into the decision engine and then get the result back in one pass. So you can see what we're doing exactly the same thing here. First of all, build an order as a test data. Look at this. The order has $2,000 orders, and this is contain like 2 line items. The first line item is a vertical file cabinet, $250, and then the second line item is a 3D printer. But this 3D printer is actually ordered by 2 cost centers, which is CC1 and CC2, right? So this is the sample data that we use for testing. Now, take a look at the decision logic. And here we are building something called business knowledge model, which is the function definitions. And here this is encapsulating the idea, the logic for auto approval and the logic for approved by job level. So you can imagine that this decision function, when it's being called by other decisions, is going to go in and set some attributes, that the attributes can be returned to an external system like an LDAP, which is used to go and really search for the approvers to approve the line items or the header. So I'm just going up the model a little bit. So this is another function definition. And here you can see that we are just doing simply mapping the cost center ID to the approval logic. So for example, CC1, the cost center ID CC1, you will need an approver from a group called marketing group. CC2 will be like from group called R&D. So this is a reusable piece of logic that we will call somewhere. Moving further up, we have a line item approval. And this line item approval is actually making use of the decision logic below, the share cost line item in a loop. So here, what that means is, if the amount of the line item is going to be less than $25, we need a manager from job level number 1, the first level manager to approve the purchase order, the line items. If it's greater than $25, we need a approval manager from line item number 2. So for level 2, which is the second level manager. So the other part is basically said, well, if I actually have distribution, which is like multiple cost center inside the line itself, I don't care about the amount anymore. I'm going to put this through this expressions, which is a loop that calls the cost center, and they go in and trying to figure out who is going to approve this line items, right? So I think the other last thing I want to show is the element which is more interesting. When we build the approval logic for one single line item, it will be used by another decision called determine all line item approvers. Here you can see that we are using the decision logic, the single line approval decision logic, and call it a loop. And this loop will actually iterate through all the line items, and then will return a list of all the approvers that need to approve all the lines. Of course, after you approve all the lines, there's still another header approval logic that we built, and we have it here, right? The header is going to be, we just make up a simple one, $25 or below, and then we get a manager to approve it. So combined, at the end, we actually have a one top-level decision that assemble all these decisions together. And this top-level decision is actually have this simple logic. For the header, which is like less than $1,000, we are going to have it auto-approve. Or else, we are going to actually call the sub-decision to do the header approvals, and then sub-decision to do all the line items approvals, and combine them and return a list to the caller. So here, we can also do the same thing, just run it, and I'll just quickly show the, so in the first, I hope you can see it. So here, you can see this is just a shape of the purchase order I showed you earlier. But when you go to the top and look at the result, you can actually see that it's a list of approvers, the attributes. For example, here you said that the headers, the PO number, which is header, is going to be approved by manager level 3. And then the first line is approved by manager level 2. And then the line number 2, because it's a multi-cost center line items, you need the approver from marketing group and approver from sales group to approve it. So I think almost done here. Just one last thing I want to show. After all of this is done, you like to expose this surface to external component for consumption. For example, a BPMN process like to call into this decision engine to get a list of approver and then act on it. So we have this decision. This is a DMN specification in which a decision surface is a way to expose the decision logic in a decision model to the external component for consumption. So here, what we can do is if you decide that the top-level decision is the one you want to expose, you just basically drag and drop into this one, and then they will save it here. And sometimes you might want a sub-decision to be exposed as well, so you can drag, let's see. You can drag and drop, and then you can add it here. So what about the input data? This order here is really just a sample data. When you expose them to the external system, you don't want to keep the sample data, in your system. You can actually put it in somewhere else, but you want to receive external input, from the service, right? So what we are doing here is that there's something called item definition in DMN that we actually when you create the input data, here we create an input data called purchase order. And when you open it up, you can see that the purchase order can be mapped to some item definition. I'll show you the item definition. For example, I'm mapping it to the order item definitions, and let's just map it. And if you look at the order item definition, it's already created. The order item definition has two fields, headers and line. And when you look at the line itself, it has the line description, amount, and distribution. And what is distribution? It's basically a cost center and an ID. So this item definitions really just provide the structure of the input data. And the input data you put inside the decision is only really for testing purpose. After the test is done, you basically remove it from a decision model, and then you create the item definitions and add them to the decisions. So here, I believe we should be able to drag and drop this. I don't know if, let's see if it's working or not. I think it's, let's see, maybe, I think it should be. Okay, yes, okay. So you can actually put the purchase order over here. Now it becomes a surface that you can expose to external, and once you save it, the surface will be exposed to external component for consumption. And I guess I hope that I can show you that when you build a very simple model, it's really easy, but at the same time, Field has the capability to allow you to build something more complex, including like loopings, multi-decisions, and all this stuff.